Can y'all hear me? All right. Now look, y'all, they're recording this, so I gotta take it from the top because I can't have like half my talk, all right? All right. Okay. Hello, everyone. No, all right. So today I want to talk about the web. The web was invented to decentralize communications, right? The ethos was anyone could publish any information to anyone in the world without the approval of any central entity, right? Of course, the web has totally revolutionized the way we interact. However, it's missing a key element, the identity layer. So applications that require a user account, they have to collect our data in order to, I got two controls. All right, they have to collect our data in order to store it with our content, right? Major powerhouses such as Facebook and Google, they try to alleviate a lot of this by enabling us to sign up and log into applications, and then we can authenticate via their services. And while this is super convenient, we have very little control over our information. What if we could own and control both our identity and our data across the web? This is possible with the Decentralized Web Platform. This platform embraces the user account model of Web 2, but it also restores control back to the users, an ethos of Web 3. On this platform, you, the developers, are enabled to build decentralized applications on top of it while it abstracts away a lot of the complexity of doing so. So there are three core pillars to the Decentralized Web Platform, all of which are based on open standards. So we have Decentralized Identifiers, also known as DIDs or DIDs. We have Verifiable Credentials, and then we have Decentralized Web Nodes. I'll walk you through each one of these. So the identifiers that we know and use today are based on, they're owned by some central entity, right? It could be the government, it could be a company, it could be an organization. For example, my email address is an identifier that's associated with me. However, this is owned by Google. My Twitter handle, near and dear to my heart, TechGirl1908, huh? Yes. This is an identifier associated with me, but Twitter owns this. And while I can manage these identifiers to some degree, I do not own them. So before we can realize a truly decentralized web, we first need decentralized identifiers because that's going to eliminate our dependency on central entities to authenticate us. So decentralized identifiers are a W3C standard, and they have a standardized structure. Wait, I'm trying to get to my little slide. Okay. They have a standardized structure. So it's basically a long string that has three parts. We have the scheme, which is DID. We have the DID method, which ultimately resolves to like a CRUD operation, so create, read, update, or delete. And then finally, we have, finally we have the GUID that represents the DID subject. When I say DID subject, I mean like the thing that is being identified. So that can be a person, that could be a company, or it could even be an object. Decentralized identifiers are the only part of the Decentralized Web Platform that's on the blockchain. And it's just this string, not any information, because Why would you put people's personal information on the blockchain? That's really wild, right? So we're not doing that, okay? Because it has the standardized structure, it can be used or stored on any of the blockchains. So the first example is a decentralized identifier on the Bitcoin blockchain. The second one is on the Ethereum blockchain. Because the information is not on the blockchain, the DID works as a URI to a DID document that's off-chain, okay? So you can think of this as like a key-value pair where the DID is the key and the document is the value. The document is stored in some decentralized storage system such as IPFS. So the DID document is basically a JSON file, and it contains information on how to engage with the DID subject. So things like their public keys, as well as authentication and verification methods. Now that is the first pillar, decentralized identifiers. The second pillar of the platform is verifiable credentials. So verifiable credentials are a fully ratified W3C standard that works hand in hand with the decentralized identifiers to enable trustless interactions. Meaning, two parties don't need to know or trust one another in order to engage. So I'm going to give you an example of how this works. So imagine that Alice wants to apply for a loan, and the lender needs to verify her employment and her salary. So her employer, Acme, would issue a cryptographically signed, verifiable credential, which Alice could then store in her identity wallet. Let me double click inside of this credential so we can see what's there. So we see we have the issuer as Acme, and we have the subject as Alice. More specifically, we have their decentralized identifiers there for both the company as well as the subject. And then we have claims that Acme is making about Alice. So they're providing her full name as well as her salary. Notice, that's all the lender needs, so that's all that's being provided. When we think about our identifiers today, our driver's license, our birth certificates, right, our passport has a wealth of information. Anytime someone wants to know one thing about you, you have to provide them all of this information. They're making copies, they're storing it on their servers. Verifiable credentials gets us around this. Just, what do you need to know? All right, here's the information, right? So, also, what's implied here is that Alice is still an active employee of Acme because issuers can revoke verifiable credentials. So when Alice no longer works at Acme, that status would be reflected in the credential itself to say revoked, all right? Last but not least, we have the cryptographic signature from Acme. So this is stored in Alice's wallet. When the lender asks her for proof of employment and salary, she could then provide this credential to them. She would also cryptographically sign it. And now the lender has an easy machine-readable way to verify these claims across the web, all right? The lender doesn't need to know or trust Alice because they view the issuer, Acme, as a trustworthy entity. Then that is sufficient to continue on with this application process. So this covers the second pillar of the platform. Last but not least, the final pillar of this platform is the centralized web nodes. So today, central entities act as our data stores, right? Applications, they host our content, they host our preferences on their servers. Decentralized web nodes changes this. It allows us to decouple our data from the applications that we use, all right? So Blue Sky is a great example of this. This is a decentralized version of Twitter, except your tweets, your connections, things like your followers and stuff like that are not hosted with the application. They're hosted with you and your own personal data stores. I want y'all to think about what that means. the following that you've built up, the brand, the persona, and all of that you've built, why would an application own that, right? When you're ready to start over on TikTok, you got to start from zero? No. With the centralized web nodes, all of this will be hosted to you, meaning you can plug that in to any decentralized social media application, all right? Your web nodes are capable of hosting public data as well as encrypted data. So if there's anything that you don't want just publicly available, you can encrypt it. In the case of decentralized Twitter, we would probably have our tweets and our connections as the public data. Things like your DMs would be encrypted. The web nodes also not stored on a blockchain, right? Because why would you want your tweets and your DMs on a public immutable ledger? You wouldn't. So again, we're not doing that. Instead, these nodes are hosted locally, and then you can replicate them across your devices and in the clouds, all right? While this is definitely refactoring the way we exchange information across the web, it is not a total overhaul of the web. Works pretty much like PWA's progressive web apps work today, except with the DWA's, the centralized web app, we would add in the decentralized web node SDK, and then these applications are free to really go serverless because they don't have our data on their servers, right? They would need to connect with our web nodes to do so. This is, remember the DID document I talked about. So if we look under the covers on how the web nodes work, our decentralized identifiers, the first pillar of the platform, basically is associated with our web nodes. So in this DID document, we would have a section for our service endpoints, and those would be URIs that point to our web nodes. So if an application wanted some information from us or wanted our data, they would send an HTTP request to our web nodes, and all of the objects in the web nodes have a semantic type. So this is an example of someone, an application requesting the social media posting objects from my web node. If that data is public, it'll just be returned back to them. If it is encrypted, then I would need to grant them permission to access that information. All right? Again, this is an example of the response. Because all of the objects in our web nodes are JSON objects and they follow some schema, it's really nicely categorized and applications can get to what they need. All right. So that was the pillars of the platform. Of course, this is pretty complex. As I tell builders all the time, decentralization is not a feature that any customer is requesting in and of itself, right? So we have to make this an implementation detail. We'll do so with an identity wallet, which very nicely designed, easy to use, lets people manage all of this. Their identifiers, their web nodes, not just the identifiers, but the context in which they'd be used, all of that, authorizations and stuff like that. All right? So, again, developers, you're enabled to build your decentralized apps on top of this platform. The platform itself is comprised of those three parts that I talked about. Each of those are open standards, meaning no one company owns them, right? What my team, TBD, is doing is implementing these standards individually and then aggregating them together to make the decentralized web platform. Once you have this, I mean, I can't even begin to imagine all the amazing applications you all can build. I'm going to share a few examples of what's possible, though. So let's say you have music app, right? These vendors have us so locked in. If you're on one music app, just the thought of like recreating your playlists and your faves and all of that on another app is just, don't worry about it, right? Even exporting, importing, that doesn't always go very smoothly. So with the decentralized web nodes, in this case, Alice has given Spotify read-write access, And again, Spotify is reading the data from her web nodes, not their servers. So when she adds a new playlist, for example, they can just write that to her web nodes using the music playlist scheme. If she wanted to then use Tidal, because they pay their artists more money, she could do so, right? By just giving them read, rewrite, whatever she wants. She can give them read access. They'll be able to see all of the playlists and stuff that Spotify wrote there. So easy peasy. Traveling. How many people flew in? So we're flying all this time, we're getting hotels, we're getting rental cars, all of these applications. We have to like repeat our preferences and all of this stuff. We have a travel app, try to manage all of this. It's a lot. Heaven forbid your flight is delayed. Now, you're at the airport, you're hustling and bustling, you're trying to call the hotel and let them know you're gonna be late. Please don't give away my room. You're trying to call the rental car, but you know they're short on cars, right? Begging them not to give away your car. If, let's say I gave the airline rewrite access to my web nodes, and I said, look, you can do whatever you want with the trip scheme. The airline can update the status of my flight. I give read access to the hotel and the rental car place, and they can pull this data without me having to call anybody, without them bothering me, and they know exactly what's going on. Oh, her flight was delayed. Let's update the reservation, all right? So these were just a few examples of what you could do with the Decentralized Web Platform. The sky is literally the limit. I know you all can make some really dope things once we have the centralized web the way it was always intended to be, all right? If you want to get more information, want to get involved, definitely check us out at tbd.website. We have links to our GitHub projects there. I'm not going to leave here giving you unicorns and fairy dust, all right? There's a lot of problems still to be solved. If you want to contribute, we welcome the help. If you want to use it, be our guest. Also, we have our Discord links on there if you want to just kind of chat it up, you have additional questions or anything like that. If you want to contribute to any of the open standards or the projects, let us know. If you want to work in decentralized space, we're working on all kind of cool decentralized technologies. We have job postings there. I have my recruiter in the audience, Lauren right there with her hand raised. All right, hit Lauren up if you want to know more about jobs. And then if you're a company, you're trying to solve some of these same problems, let us know. We're happy to collaborate, all right? All right, y'all, so that completes my talk, the Decentralized Web Platform. Y'all be easy.
All right, all right, all right.